Okay, converge or diverge, the series when n goes from 1 to infinity, sine of 1 over n. And as a good habit, we should always check the limit as n goes to infinity of this, right? Okay, 1 over infinity is 0, and we know sine of 0 is 0. Unfortunately, the test for divergence in our case wouldn't work. We have to do more work for this, right? What can we do though? Well, we see that the input here is 1 over n. And if we just focus on the series of 1 over n, we know that diverges because that's the harmonic series, right? So we know something much better. Therefore, we can try to use one of the comparison theorem to make the connection with this, right? Okay, so now it's just a matter of us to write down the format, right? All the reasoning and things like that. First of all, I'm just going to write down what we know, which is the series when n goes from 1 to infinity, 1 over n. And we know this right here diverges because it's the harmonic series, right? And for the reason right here, I can just say the harmonic series diverges, right? So that's what we are going to use. And now we are going to make a comparison. Okay, we have two versions of the comparison test, right? Either the direct comparison, meaning we have to check inequality, or we can do the limit comparison, meaning we do the limit. Well, in this case, because of the trig function here, it will be a better idea to try to use the limit comparison test, right? So here is the check. And as usual, we are going to check the limit as n goes to infinity. And let me just write this down for you guys. If I put down n goes to infinity as how we usually would do it, all right? And I'm just going to put down the original right here on the top, which will have sine of 1 over n. And then we will divide this by this, the things that we know much better, which is 1 over n, right? Okay, how can we check the limit of this? Technically, we can still plug in infinity into the n here, right? On the top, you get 0. On the bottom, you also get 0. This is a 0 over 0 situation. So what do? We have to utilize L'Hopital's rule, right? But the problem with this is that we cannot put down dn. We cannot differentiate with respect to n because n is technically just a bunch of whole numbers. So with that being said, in our case here, I'm going to actually change this to x. So I can legitimately use the L'Hopital's rule. So x goes to infinity. Let's check sine of 1 over x over 1 over x. And we still have 0 over 0, but we can use L'Hopital's rule now. And we can just put down dx, dx, all right? Okay, so I will draw an arrow. Well, actually, I'm going to draw an arrow because this is going to be approaching to what happens next, right? Anyway, here, when we do the sine of 1 over x, derivative sign, we know it's cosine, and the input stays the same, which is 1 over x, but we have to multiply by the derivative inside. The derivative of 1 over x is negative 1 over x squared, okay? And this is over, we differentiate 1 over x, and it's just the same as that, right? So the derivative of 1 over x is negative 1 over x squared. And you see this and that cancel each other out completely. And you see this is going to be approaching to cosine of 1 over x. And as x goes to infinity, depending on how much work you want to show, you can write this down as cosine of 1 over infinity, which is, approaching to 0 inside, so this is cosine of 0. And we know cosine of 0 is 1, so the whole thing right here will approach to 1. And now what? Is this a good number for to-do scale or not? Yes, it is. Every time after the result of a comparison test, the limit comparison test to be specific, as long as this number is bigger than 1, bigger than 0. As long as this number is bigger than 0, then this is a good number to use. This right here, okay, draw a conclusion because this limit is bigger than 0, right? This is 1, which is bigger than 0. So, at the end, we'll just go ahead and write our conclusion. And the conclusion is that the original series, the series when n goes from 1 to infinity, sine of 1 over n, this right here also what? Diverge. Just like that, right? This right here also diverges. And the reason is because, and now we have to quote the test that we use, right? By the limit comparison test with the one that we put down over there. Sigma when n goes from 1 to infinity, 1 over n. And this right here is it. Remember, put down what you know, do the check, at the end, draw a conclusion, and be sure you have to pay close attention to the result right here. Can we really use this number here to draw a conclusion? It was bigger than 0, therefore it was okay for us to continue to move on here to draw a conclusion. And that's it.